Hello everyone, let's talk about another medium problem on Leetcode today. Continuous subarray sum, Leetcode 523. In this, we are given an integer array nums and an integer k. We have to return true if nums has a good subarray, or we return false. And then they have defined good subarray as the subarray where the length is at least 2 and the sum of the elements of subarray is multiple of k. Note that subarray is a continuous part of the array, so that is one thing. Then they have defined multiple as well. An integer x is a multiple of k if there exists an integer n such that x is equal to n into k, and 0 is also the multiple of k. Then they have given some examples as well. In the first example, we can see that nums is 23, 2, 4, 6, 7 and k is equal to 6. Then we can see that there exists 2 and 4 as subarray where sum is equal to 6, and that actually makes a good subarray, and that's why we return true. Note that there is also 6 present. That's also a subarray, but it's not a good subarray because the good subarray at least should have a length equal to 2. Then in second example, nums is equal to 23, 2, 6, 4, 7 and k is equal to 6. And then if so, one of the subarrays we can see is like 2, 6, 4, that sums up to 12, right? And then they have also given another subarray like 23, 2, 6, 4, 7, which actually sums up to 42, and that is the whole array, right? So that's also a subarray. It's also the multiple of 6. So that's why we return true again. Now let's jump into the solution space. Now, first thing to note is that we don't have to find any largest or smallest subarray. We have to just find if there is some subarray which is at least of size 2 and the sum of which is actually the multiple of k. So that makes our life easier. Second thing to note is that prefix sum will not work, right? Because it works only when sum is equal to k. So it works by luck. Now let's look at the example. We have this nums array, right? 23, 2, 4, 6 and 7 and k is equal to 6. Then we can calculate the prefix sum by just adding the elements when we are moving the array from left to right. So it will be initially equal to 23, then we add 2 to it, then it becomes 25, then we add 4 to it, then it becomes 29. Similarly, 29 plus 6 will be 35, and then 35 plus 7 will be 42. So that will be our prefix sum. Then the prefix sum for it will be 23, 25. So we can see that the difference between two elements like 23 and 29 is 6. So that means we have found our answer, and we can return true in this case because the indices difference is at least 2. So in this case it works, but where it doesn't work is this case where again k is equal to 6. So we can create a prefix sum 23, 25, 31, 35 and 42. Now we find the gap between 25 and 31 is actually equal to 6, but because the index gap is only 1, this is not our good subarray, right? So we will continue. And similarly, we will reach the end of the array and we will not find any sum which was equal to k, right? So that's why this solution will not work as is. Also note that programming languages have integer division, so calculating multiples may be a bit tricky, but then which operator can actually help us doing this? And the answer is modulus operator. Let us see how the modulus operator works. So if we have two integers x and k, when we apply the modulus operator on x, we get the remainder a such that a lies between 0 and k minus 1. Let's say x was 9 and k was 7, then the modulus operator will return output as 2. But suppose if x was multiple of k, say 14, and then we apply modulus operator 7, then we will get 0. So either it will be 0 or it will be 1, or at maximum it will be k minus 1 or 6 in this case. Second thing is, note that if two values give the same remainder, so x and y are different variables, but they give same remainder a, that means x is a plus some multiple of k, right? And y is also a plus some multiple of k. M and n are two integers. So let's look at some example. So suppose x was 2 and y is equal to 100 and k is equal to 7. In this case, we will get a equal to 2 for both of them, right? So x is 2% 7 and y is 100 is equal to 14 into 7 plus 2. So n was equal to 14 basically, but the remainder will still be 2. So this gives us a relation, right? That when the remainder is same and the values are different, then the difference between those two values or the difference between those quotient will be the multiple of k. So in this case, 2 and 100 were two numbers and difference between them was 98, and k was equal to 7, which is, and 98 actually is multiple of 7, right? Now we have to add all the numbers in the array and apply the modulus operator on it. But before that, let's add two numbers and try to find some pattern there. And this is where we can see the distributive property of modulus operator. Now suppose we have two numbers x1 and x2, and we apply the modulus operator with k on them, and we get two remainders a and b. Then what will be x1 plus x2 modulo k is equal to? Actually, the answer is not that surprising. It will be x1% k plus x2% k. That is a reminder. That is a remainder from a and b percent k, and that is c is equal to a plus b percent k. So c is actually equal to sum of the reminders and then applying the modulo operator there. So let's look at some examples. So suppose we had two numbers, 8 plus 6, right? And we apply the modulo operator, say with 7. Then the answer in this case will be 14 modulo 7, that will be equal to 0. And now let's try to apply the distributed property. So we can say, okay, 18% 7 plus 6% 7 and percent 7 again, right? So remainder from 8 will be 1. Then 6 modulo 7 will also be equal to 6. So this will give us 7. And then when we apply the 7 modulo 7 here on this, we actually get equal to 0. So to sum it up, the distributive property of the modulus operator ensures that the results are consistent, whether we apply the modulus operator early, like term by term, and then applying the modulo operator again on it, or we apply the modular operator at the end after doing the addition of all the numbers. And I will say, like, when we apply the modulo operator early, like in this case, we are doing x1% k plus x2% k and then applying the modulo operator on whole of it. This actually avoids integer overflow when we are performing such operations. Now let's come back to the array. When we apply all these properties, so one thing we can note is that we can apply the modulus operator eagerly, that is like term by term. So that is one thing, so that will avoid overflow. But then we also note that if at any point the prefix sum modulo k become equal, suppose this was a and then again we get a reminder a, that means whatever difference between we had these two prefix sums modulo k was actually the multiple of k. If you remember, we saw it in the property here. And now let's jump into the dry run part. So suppose k was equal to 9 and this was our input array 23, 2, 1, 6, 7. So we can see that 23% 9 is equal to 5. So this is our initial prefix sum. Now I becomes 1. That is, we are now at the second element. What we could have also done is like 23 plus 2% k, which would have given us 7, right? But what we can also do is, because our previous prefix sum was 5, we will just add 5 plus 2 to it and 2% 9 on this. So this will also give us 7. So we don't have to keep on adding and then only doing the modulo operator. So similarly, we will build the rest of the prefix array. So we can see that 5 occurs 2 times, like 5 occurred earlier as well. And now 5 has occurred again. That means the sum between these value will be a multiple of k. So that's how the whole modulo operator properties will work. And how we will check just by going back is like we can actually store these values in the map with the index, and whenever we see value with a different index and the difference between those two indexes at least 2, then actually we have found our answer and we will return it. Now one more important edge case is like initially when nothing was added, our sum was equal to 0, right? And if we find some value where again we get the value equal to 0, that means the whole sum so far was actually multiple of k, because 0 is also one of the multiples of k. So that's the edge case we have to take care of. So we will put -1 in the map we will put 0 in the map for index -1 basically to handle this kind of edge case. Now let's jump into the code part. So first thing we will define is a map of prefix sum mod k and the index at which this prefix sum exists. And what we will also do is we will just put initial value. If you remember, for the edge case, for sum 0, our index will be -1. So that if we see the sum 0 again, we actually find one of the answer. We try to find one of the answer as well. Now we have taken care of this edge case. So we will now define prefix sum mod k, and initially it will be equal to 0. And now we can start looping on the nums array. So we will just do prefix sum plus equal to nums I and also apply the modulo operator on it. And now comes the interesting part. If map contains this prefix sum, if map does not contains, let's take that easier case first. Then we will just add it to the map with the corresponding index. Otherwise, we will see if we have actually found the answer. So else if I minus map.get prefix sum mod k is greater than 1, that is the index difference is actually more than 1, then we will just return true. Otherwise, we will just return false because we at least need 2 elements to begin with. Let's try to run this code. Awesome. Let's submit it. Cool. It beats 50% of the people. And in terms of time complexity, we actually are adding n elements. We are also calculating the prefix sum mod k for that. Again, all of this takes O of n time. Adding the value to map actually takes O of 1 time, and also getting the value again takes O of 1 time. So in total, the time complexity in this will be O of n. In terms of space complexity, it will be O of k because map at maximum will contain k prefix sums mod k in the map, and that will be our space complexity. I hope this video was useful to you. If it was, please like and subscribe, and do comment which part you like and where I can do better. Thanks again. Have a nice time.